Next, I'm going to go through example E1.3 on page 13 in the book. And what they're asking for you to do is to determine calculate the magnitude and the direction of the net force in terms of Q, the charge, and D, the distance. And so we have our figure here. We have charges Q1, Q2, and Q3. And we want to find the net charge on Q1 in terms of those quantities. So we don't have any numbers. We're going to keep our answer in terms of the letters that represent those numbers. Okay, so if we want to calculate the force on Q1, so we have the force on 1 is going to equal the force on 2 plus the force on 3. So we have the force on 1 due to 2 plus the force on 1 due to 3. Okay, notice that my force, the magnitude of my force is equal to K times some Q1, Q2 over R squared, the distance between the charges. Notice in the book that they use 1 over 4 pi epsilon naught. And remember from my little lecture that K is equal to 1 over 4 pi epsilon naught. So I can just use, whenever I see that, I can plug K in instead of plugging in pi and 4 and epsilon naught. Okay, so let's figure out what now notice if I calculate my force, right, my charges, my Q1, my Q2, and my Q3, the values of the charge are all the same. So the numbers that I plug into Q1 and Q2 are going to be the same. K is the same, and R the same. So is the distance from Q1 to Q3 and the distance from Q2 to Q1, is that the same? And because this is an equilateral triangle, meaning that the angles, so if I draw the lines here, this is an equilateral triangle, so I know that all of the angles are equal. This angle is 60 degrees, this angle is 60 degrees, and this angle is 60 degrees. And I also know that all my sides of my equilateral triangle are all equal. So that tells me that the magnitude, the value of the arrow for the force is going to be the same. So that tells me that F1, 2, the force on 1 due to charge 2, is equal to the force on 1 due to 3. That is the magnitude, that those are equal. And so let's figure out what that is. I guess we have it already. We have KQ1 Q2 over R squared. So we'll write that as KQ squared because we know that the charge Q is equal to Q1 is equal to Q2 is equal to Q3. So we're just going to represent that charge as a Q. So KQ squared over, and let's call the side, one of the sides here D for distance. So we'll say that's equal over D squared. So that's the magnitude, the value of the force. And now let's figure out what the direction. So I'm looking for the force on Q1 due to Q3. And because these charges are the same charge, we know that they repel each other. So that means that the force on this one due to Q3, it's going to push it away. So this is my force is going to be directed away. So that's going to be my force on 1 due to 3. Okay, so it's a vector, and so I want to be able to break that into its components and write F13. So let's write F13 is a vector, and we want to figure out what the x and the y component of this vector are. So what I can do is I can draw the components here. That's my Fx for 1, 3, and this is my Fy. Okay, so I'm going to have F13, and now I have to figure out what this x component is. And if you look through the lecture, we go through this, how we figure this out, and we find that if this is my angle, this is theta, then I know that Fx is adjacent, it's next to the angle, so that's cosine. So I would have cosine of theta is equal to Fx, the adjacent side, over the hypotenuse, which is F13. So now I multiply both sides by F13 to get rid of the F13 and get Fx alone. and I find that fx is equal to f(1,3) cosine theta. So that's what I can plug in here, f(1,3) cosine theta. And now what about the y? Well, the y is opposite the angle, so now I know that, so I can say sine of theta is equal to fy over f(1,3). Again, I can multiply both sides by f(1,3), which allows me to get fy alone. So fy is equal to f(1,3) sine theta. So I can plug in f(1,3) sine theta. And we've defined this to be in the page, right? And so fz would be into or out of the page. And so since we're not, we're only in the z equals 0 plane on this page, we're going to say this is equal to 0. Now what about our sines? So if I